From searing heat waves to drenching floods, extreme weather events around the world are causing devastation and death on an ever-increasing scale. And with Earth's average temperature now more than 1 degree higher than it was in 1900, the planet's tipping points are coming closer and closer. So, here's the question. Is our homeworld now past the point of no return? And if so, are we really willing to let it go? Or will we take matters into our own hands and play God? Today, we're diving into the wild world of geoengineering, a term that encompasses any large-scale intervention in the Earth's system to counteract human-caused climate change. But before we get started, be sure to hit that subscribe button for more thought-provoking science videos. In this installment of SCI Show and Minute Earth, we'll explore two of the most promising techniques in the geoengineering toolbox, the possible pros and cons, and the ethical considerations of potentially dooming or saving the planet. Strap in, because this is one wild ride. If you've seen SCI Show videos on climate change before, then you know that we solve this problem by simply scrubbing the planet's surface clean of every coal plant and deforestation project. We'd also need to pull vast amounts of carbon dioxide out of the atmosphere. This is a huge task, since there are already billions of tons of excess greenhouse gases in our skies. One proposed solution is solar radiation management, or SRM, which involves reflecting some of the incoming sunlight away from the planet. Stratospheric aerosol injection. One type of SRM involves injecting aerosols, such as sulfate particles, into the stratosphere, the second layer of the atmosphere, where they'd linger for several years. The idea is that these particles would reflect some of the sun's rays back into space, counteracting some of the warming effect caused by all that extra CO2 hanging around in the atmosphere. Marine cloud brightening does something similar by dispersing seawater droplets into the air above the ocean, which then thicken the clouds and increase their reflectivity. But let's face it, shooting stuff into the sky sounds like playing God, doesn't it? And that's not even the half of it. While SRM could theoretically slow down or even reverse some aspects of the global climate crisis, it also comes with a lot of unknowns and potential risks. For starters, scientists don't exactly know how these interventions would impact regional climates. Dispersing aerosols over the ocean could alter rainfall patterns, wind speeds, and temperatures across the globe, potentially disrupting ecosystems and putting people at risk of starvation or displacement. Plus, it's hard to predict how well these methods would actually work, especially considering that multiple factors influence Earth's climate. What if a cooling technique designed for one area ends up creating a disaster somewhere else? These uncertainties highlight the complexity of geoengineering and why we need to understand its potential consequences before proceeding. And that's just one side of the coin. There are other potential downsides to consider, too. One major concern is that geoengineering could distract us from reducing greenhouse gas emissions, both through more energy-efficient practices and by switching to renewable energy sources. After all, if we think we can just inject some aerosols into the atmosphere and everything will be all right, why bother changing our energy consumption habits? In fact, that's one of the main reasons why many scientists argue against geoengineering in general. It poses what's known as a moral hazard, meaning that it could make people feel safer and reduce the pressure to cut emissions. And that's far from ideal. But even putting aside the moral hazard argument, there are other reasons why we should tread carefully. Some people worry that geoengineering could lead to conflicts between countries. If one nation deploys geoengineering techniques unilaterally without the consent of others, it could trigger what some have called climate wars, potentially sparking a geopolitical disaster. Others worry about intergenerational equity, arguing that we should unsaddle future generations with the responsibility of dealing with the consequences of our actions. Like, what if we start deploying geoengineering techniques and then decide that we want to stop? Without knowing how these systems work, we don't know what would happen when we turn them off. Some scientists predict a termination shock as the planet's temperature rebounds to new highs, leading to more extreme weather events than before. This abrupt shift could cause widespread crop failure, displacement, and conflict, making the current climate crisis look like small potatoes by comparison. These concerns are not merely hypothetical. They're backed by serious research conducted by experts in various fields. For example, in a 2021 paper published in the journal Environmental Research Letters, researchers from Harvard University outlined the potential consequences of unilateral geoengineering deployment. Their findings suggest that such actions could strain relationships between countries and exacerbate existing tensions. Similarly, a study published in 2023 in the journal Nature, Nanotechnology explores the ethical dimensions of geoengineering research. The authors argue that the potential risks and uncertainties involved in these technologies require careful consideration and public engagement before any large-scale deployment. But let's take a step back and consider the other side of the coin. Maybe we won't let future generations shoulder the burden of this decision alone. Instead, we'll tackle the climate crisis head-on with bold innovation and ingenuity. Enter carbon dioxide removal, or CDR, a suite of techniques aimed at pulling carbon dioxide directly out of the atmosphere. One of the most promising approaches is direct air capture, or DAC, which involves using machines to suck carbon dioxide out of the ambient air. The captured carbon dioxide can then be stored underground or in other geological formations, such as deep ocean waters. While DAC has the potential to remove significant amounts of carbon dioxide from the atmosphere, it also comes with its own set of challenges. For example, it's an energy-intensive process that requires a lot of electricity. This means that DAC needs to be paired with renewable energy sources to truly be effective. Additionally, there are concerns about the safety and longevity of storing carbon dioxide underground. What happens if the storage site leaks, or if the geology of the area changes over time? Another approach to CDR is bioenergy with carbon capture and storage, or BECCS, which combines growing trees or other vegetation with DAC. The idea is that the carbon dioxide removed by the plants is stored in biomass, such as wood or crops, which can then be used as fuel to generate electricity. However, BECCS also comes with its own set of challenges. For example, growing plants for bioenergy competes with food production, meaning that we'll need to use land and resources to grow fuel instead of food. Additionally, there are concerns about the sustainability of growing biomass for this purpose. What if the plants end up using more energy than they produce? Despite these challenges, some experts argue that CDR is an essential tool for solving the climate crisis. Proponents of CDR argue that it can help us reach net zero emissions, which is a key goal of the Paris Agreement. By removing carbon dioxide from the atmosphere, CDR can help us balance out the emissions we produce, allowing us to continue using fossil fuels while still meeting our climate goals. Here's the thing, though. Even though CDR looks great on paper, we may be living in the wrong era to deploy this tech on a large scale. You see, even with all the hype surrounding AI lately, we're still quite a few years away from machines that can learn to fish for plastic in the ocean or revolutionize agriculture. So, at least for now, it's unlikely that we'll be able to use these techniques on the scale necessary to prevent catastrophic climate change. So perhaps the best course of action is to focus on developing and refining these technologies responsibly, which means ensuring that research is conducted ethically and with the utmost care. It also means being transparent about the risks and uncertainties involved in geoengineering and engaging the public in discussions about its potential consequences. We're at a critical moment in history as we grapple with the unprecedented challenges posed by climate change. The stakes couldn't be higher. But as we look to the future, we must remember that we're not just fighting for our own survival. We're also fighting for the survival of countless other species and ecosystems that share this planet with us. The decisions we make today will have ripple effects for generations to come. But despite the challenges ahead, we can take heart in the progress that we've already made. Thanks to innovations in renewable energy, electric vehicles, and energy efficiency, we're on the cusp of a new era of sustainability. The path forward won't be easy, but with each step we take, we're moving closer to a cleaner, greener future. So here's the question I challenge you to ponder. Are we on the brink of a climate catastrophe, or are we poised on the threshold of a sustainable future? Let's have that conversation. Want to learn more about the science behind climate change? Check out our video on how climate change impacts you. And thanks for watching.